Humans are leaving Earth's orbit for the first time in half a century, carrying digital sensors designed to capture the mechanics of deep space. The Artemis II crew spent 2 years training with imaging specialists at the Johnson Space Center. They were learning to go beyond basic photography to capture high-fidelity data required for planetary science. Pushing a crewed capsule out of the atmosphere and toward the moon requires nearly 160 million pounds of thrust from the Space Launch System. NASA integrated high-resolution imaging into every stage of the flight plan, ensuring this journey produces a primary visual record of humanity's departure from Earth. The first images from the cabin were familiar. Using iPhone 17s, the crew documented their departure with selfies, capturing the reflection of the planet in the Orion windows. As the spacecraft accelerates toward the lunar sphere of influence, the scale of that reflection changes, with the Earth's presence in the window rapidly diminishing. By utilizing long exposure settings, the crew recorded the faint green luminescence of auroras swirling across the magnetic poles, a perspective of our planet's energy usually invisible to the naked eye. This sequence of images turns our global environment into a small, isolated sphere, setting the stage for the moment it disappears from view entirely. As Orion reaches the moon, the visual focus shifts from the receding Earth to the heavily cratered lunar topography. The terminator is the abrupt boundary between lunar day and night. With no atmosphere to scatter light, this line is razor-sharp. Grazing sunlight reveals basin structures like Vavilov crater, creating jagged shadows that expose 3D ridges hidden under direct illumination. These extreme contrasts transform the familiar lunar disk into a complex, physical terrain of jagged vertical relief. The mechanics of the lunar flyby require Orion to physically swing behind the moon's far side. At 6:41 p.m. Eastern, the crew documented a crescent Earth sinking behind the gray lunar horizon, the first Earthset witnessed in over 50 years. Passing behind the moon's bulk physically blocks the path of radio signals, cutting all contact with mission control. For 40 minutes, the crew drifted through the lunar shadow, completely cut off from every signal and voice on their home planet. This blackout represents the furthest physical and digital separation between humanity and its home since the Apollo era. Contact was restored as Orion's orbit carried it back around the lunar limb, re-establishing a direct line of sight to Earth. The crew captured a bright blue Earth emerging from the void, documenting the relief of seeing their home world reappear over the gray horizon. This orbital alignment created an unprecedented viewing opportunity, a total solar eclipse witnessed from deep space. Because of Orion's position, the moon blocked the sun for nearly 54 minutes. This unique geometry allowed the astronauts to record solar phenomena for a duration that is physically impossible to achieve during eclipses on the ground. The crew used this time to photograph the solar corona, identifying background stars and the silver glint of Venus, details typically lost in the sun's glare. These images provide heliophysicists with a primary record of the sun's outer atmosphere, captured from a vantage point outside the interference of Earth's own environment. The Artemis II portfolio serves as the definitive visual evidence of this transition. It documents the exact moment our world recedes into the background, becoming one small station within a much larger orbital system.